All right, on to the next set of questions in chemical bonding, जिसमें एक से ज़्यादा सही जवाब हो सकते हैं. ओके, पहला सवाल, इनमें से किसके बॉन्ड ऑर्डर आइडेंटिकल होंगे? यू नो द ड्रिल, राइट? इफ द नंबर ऑफ इलेक्ट्रॉन्स इज 14, दैट्स isoelectronic nitrogen, that has a bond order of 3. If it becomes 15, this becomes 2.5. If it becomes 13, it becomes 2.5, so on and so forth. I've done this multiple times in theory session, जाके देख लेना आराम से. As always, यहाँ पे focus है सवाल जल्दी से quickly figure out करना और solve करना. Okay, so carbon 6, this is 7 and plus 1, so that's 14 electrons इसमें. Oh, like nitrogen. Okay, what about this? Well, this is not nitrogen obviously, right? Well, it could be actually. हाँ, ये भी 7 है और 8 minus 1, right? Because okay, मुझे तो 1 और 2 ही सही लग रहे हैं. Let's see if there are more. ये दोनों तो सही हैं for sure. ये दोनों isoelectronic हैं. और भी कोई 14 है क्या? नहीं, this was 16 plus 1, so that becomes 17. 16 plus 2, that becomes 18. Oh, there you go. That's the answer. Which of the following attains क्या अजीब ग्रामर है. Linear structure. ठीक है, BCl2. Yeah, sure. BCl2 is linear. NCO plus what? NO2 non-linear. NO2 is non-linear. What is NCO plus? You're gonna ask me, like, yeah, I think we'll stay away from it because it's a bit of a debatable thing. I mean, ये तो शायद आप इसका structure जानते होंगे. You can do plus minus etc. CS2 is like CO2 and it's linear. ठीक है. So these two work out. NCO plus is not linear according to NCERT. Some places chemistry stack exchange बोल रहा था was linear. So I'm just going to leave this as a question mark because for some reason NCERT से directly आजकल सवाल आ रहे हैं. तो if this comes in JEE, just mark these two and don't mark NCO plus. Advanced I hope won't do things like this. खैर, debatable thing about NCO plus, मुझे भी लगता है linear है, but no concrete data to support either way कि linear है कि bent है. CO is isoelectronic with what? CO isoelectronic 6 and 8, so that's 14. अच्छा, with nitrogen. Ta-da! But this is more than one correct. NO2 में तो 3 है, essential to know, not these two. NO plus, possible? Let's see. 7 plus 8 minus 1. Yay! There you go. 1 and 2 on question number 25. इनमें से कौन से species का same shape है? This is linear. Okay. और कोई लीनियर है क्या? नहीं, ये तो टेट्राहीड्रल हो गया. CCl4, O3 is bent, you know this. NO2 minus also bent, right? The way you write it is this, etc. Okay, yeah, so I think the answer here is 3 and 4. Easy one because ये वाला लीनियर है और ये वाला टेट्राहीड्रल है, इसीलिए ये दोनों सही हो जाते हैं. Let's move on. If you're not sure about structure of ozone and all of that, theory में देख लेना please. Theory sessions में देख लेना. Which of the following statements are correct about CO3 2 minus? Hybridization is sp3. नहीं तो ये तो sp2 होगा ना. What is CO3 2 minus? You had like solid bonds and then you had like dotted things showing that there's partial double bond character on all of these, and then you take this together and there's 2 minus, right? That's what this was. The resonance structure ये था, has one CO. No, that's not the resonance structure. That's the one of the structures that shows the contributes to the resonance structure, but together ये resonance structure मैंने draw किया है. NCERT theory में है directly. The average formal charge on each, this one's interesting point. This is a weird question. All CO bonds length are equal. This is okay because ये दोनों गलत है. You can guess to say कि ये भी सही है, but if you want to explore this, what is formal charge anyway? It is total number of valence electrons in oxygen, which is 6 in both cases, minus non-bonding electrons. Okay, let's see, minus number of bonds, right? और bonded electrons by 2 etc. Same चीज़ है. So if I look at this structure, थोड़ा ठीक से draw करते हैं इसको. एक में double bond है, एक में single bond, बाकी दोनों में single bond. Okay. If you look at this oxygen, okay, let's call this 1. इसके लिए valence electrons 6 हो गए, non-bonding electrons हो गए 4 and bonds हो गए 2. तो यहाँ पे हो गया 0. This is 2 and 3 which are equivalent. So I'm just going to put a whatever इसका आएगा, इसका भी आएगा. Number of this is this 1 2 3 4 5 6. Don't forget those 6, the other lone pair as well. तो 6 electrons हैं यहाँ पे, ठीक है. 6 नॉन बॉन्डेड इलेक्ट्रॉन्स हैं. ओके, एंड एक बॉन्ड है जिसकी वजह से हो जाता है -1. सो यू गॉट अ फॉर्मल चार्ज ऑन 2 ऑफ दीज टू बी -1, ऑन 1 टू बी 0. सो -2 डिवाइडेड बाई 3 बिकॉज देयर आर 3 ऑक्सीजन एंड इट कीप्स, देयर ऑल इक्वलेंट, राइट, और बदलता रहता है. सो दिस is how you get 0.67. A little bit weird, but this is the answer to this one. आगे बढ़ते हैं. Diamagnetic species are those which contain no unpaired electrons. Which of these are diamagnetic? Interesting. The easy thing to do is अगर कोई odd electron species दिख रहा था तो okay, नहीं उससे भी नहीं होता. No unpaired electrons. Okay, nitrogen. This has unpaired electrons, right? How do I figure this out? Well, with the whole 8 electrons पहले, फिर what comes first? Pi 2p y, yes, equal to pi 2p x, and that's less than sigma 2p z, etc., etc. So 8, 9, 10, 11, 12, 13, 14. Oh, look at that. ये तो diamagnetic है लग रहा है. Yeah, इसमें unpaired कुछ नहीं है. 28 was 1. Yeah, it always takes me time to do this because I do things in first principle. Then I suggest that to students as well, right? Oxygen का कैसे होगा? 2pz less than pi 2px equal to pi 2py. तो 14 तो यहाँ पे हो गए और उसके बाद क्या होगा? After this, you've got good old, क्या करें यहाँ पे? You need to have pi star, was it? Right? Pi star 2px equal to pi star 2py, and then after that you need to do this whole sigma star 2px, right? That's the difference between oxygen and nitrogen. Okay, good, great. ये सब क्यों लिखा? Because ये तो diamagnetic है. अब बाकी इसको देखने के लिए you need to spend some effort. This is not diamagnetic. If you remember theory, this is paramagnetic, right? कि 14 तो fill up हो गए, then 15, 16. Let me change the color to show you something else. Then maybe कौन सा वाला करना था? दूसरा वाला oxygen. Let's use blue. What color would look nice on this? Another dark color. Let's say brown. Let's use brown over here. दिखता है? दिखता है. Great. Okay. O22 minus plus 1 plus 1. This happens to be diamagnetic, right? So ये दोनों है diamagnetic. This is definitely not, and theory में भी काफी होता है. And similarly, you can go ahead and look at nitrogen, which would have what? इसके बाद क्या आएगा? Pi star 2px. This is a little debatable. कभी-कभी they do this or they put the other one first. But anyway, the main idea is कि अगर मैं एक यहाँ पे electron डालूँ, this becomes paramagnetic as well. ठीक है? तो we have figured out with a little bit of effort, maybe you can just remember the theory that 1 and 4 are definitely diamagnetic. See, bonding में यही चक्कर है कि या तो तुम पूरी theory मग कर लो और you do this on the fly when you know the theory. When you know the theory and you need to apply it a little bit. Or you just know कि hey, ये paramagnetic, ये diamagnetic. I would suggest that you do it this way. I'm comfortable like this. And it's okay to spend a little bit more time on this. But पक्का करो क्योंकि कभी-कभी अगर मग करने में गड़बड़ी हो जाए, that's risky. But if you're confident, whatever works for you. Species having same bond order. Remember, 14 was 3. 15 was 2.5. I know मैंने ऊपर लिख दिया. ठीक है, no problem. This is also 2.5. So on and so forth. Okay, nitrogen is 14. Well, obviously it cannot be the same as 9 2 minus. I just told you this is going to be 2.5. And also odd electron species. There's no way that these two can be the same. Okay. Looks like ये दोनों same हो गए, right? O2 minus मतलब कि 16 plus 1 17 and F2 plus मतलब कि 18 minus 1 which is 17. Yeah, 17 same electrons. So isoelectronic species, so they have the same bond order. 29 would be 3 and 4. Look at that. We've come to the end of this multiple, more than one correct answer. Don't worry, we have a couple of more assertion reason or interesting questions left. Which of these statements is not correct? Which of these statements is, R, okay. Because more than one correct. Okay, cool. NaCl being ionic compound is a good conductor. No, of course it's not a good conductor actually in solid state. What are you talking about? It's not correct. Oh, okay, hold on. Let me think about this. No, ये तो सही है. This, no, hold on. Thinking again and again. See, okay. Which of the following statements is not correct? NaCl, yeah, this is incorrect, which makes it the right answer because they're asking what is not correct. In canonical structure, there's a difference in arrangement of atoms. Nope, there's a difference in arrangement of electrons. So we got 2 correct already. Let's see what happens here. आगे. Hybrid orbitals form stronger bonds than pure orbitals. ये वाला सही है. Hence, not our answer. CPR theory can explain. All right, great. This is it. I'm skipping over short answer. You can figure that out on your own. Theoretical things match the type. कर सकते हैं, but it's all right. You'll figure it out. Let's go to assertion reason. Sodium chloride formed by the action of chlorine gas on sodium metal is a stable compound. Sure. This is because sodium chloride ions acquire octet. Yeah, this is a weird question. Answer is 1. Yeah, let's not think about this one. Through the central atom of both, though the central atom of both nitrogen, NH3 and H2O are sp3 hybridized, NHN bond angle is greater. Yeah, because repulsion ज़्यादा है दो lone pair में जो oxygen है. Oh, that's what the reasoning is saying. This is also correct. One lone pair, oxygen has 2. ठीक है. 59. Among the two OH bonds in H2O molecule, the energy required to break the first OH bond and the other OH bond is the same. Nope, that is incorrect. क्यों? अगर मैंने एक bond तोड़ दिया, then I have this OH minus ion. That's crazy, because then if you break that, you get O2 minus, and that's not going to happen. It's going to take a lot of energy. This is because the electronic environment around oxygen is the same. No, it's not. It's different. We've just shown you that, right? So दोनों चीज गलत है. Is there an option that says that? Yes. 59th is option 4. Right? We good, right? We good. Just check if what we're doing is okay. Okay, let's skip over the long answer ones. There's an interesting set in the end. There's a comprehension. Ooh, long comprehension. Look, it's just explaining what is bonding molecular orbitals A, B, MO, and wait, let's check. जो मैंने सही ऊपर लिखा था कि नहीं. This is for nitrogen. Okay, great. Yeah, pi star. Cool. This is for 14 and lower, and this is greater than 14 electrons. Less than equal to 14 and greater than 14 electrons के लिए ये वाला setup है, right? Okay, cool. Sigma bond, pi bond के बारे में बात कर रहे हैं. Okay, this is just general theory. Let's look at the first question, 65th one. Which of the following statements is correct? In the formation of dioxygen from oxygen atoms, 10 molecular orbitals will be formed. Interesting. 10. Okay, let's see. So I've got this to be the oxygen, right? So 8 चले गए, right? This is get cancelled out. I've done this multiple times. 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like we're good with 9 orbitals. So is this option incorrect? Well, come on, please think a little bit, right? If you're going to form a bonding molecular orbital, you also have to form an anti-bonding molecular orbitals, right? It's not one or the other. दोनों form होते हैं. You remember this, right? Psi A plus psi B and psi A minus psi B. This is ABMO, this is BMO. This is a theory of molecular orbital theory generally, yeah? Linear combination of atomic orbitals is what gives you molecular orbitals, etc., etc. So this is good, actually a really good option. It could confuse students. You do need 10. I mean, 10 are formed, whether they get filled or not, 10 get formed, okay? But if you keep on reading the other options, you'll see that this, ये जो चीज़ मैं बोल रहा हूँ, वो बिल्कुल logically बैठती है. All the molecular orbitals are dioxygen will be completely filled? No, because 10 थे, 9 ही filled हैं. हमने अभी देखा. Total number of bonding orbitals will not be the same as total number. देखो, this is wrong. We just said that it has to be the same. Number of filled bonding orbitals will be same as number of filled. If that was the case, by the way, number of filled, no, actually no. We don't have to think about this too much. Look, this is one ABMO that is unfilled, whereas all the bonding molecular orbitals were filled. So it's 5 versus 4. 5 versus 4 if you want to do that specifically. 5 hai bonding, anti-bonding is 4. Cool question, actually the most interesting question, in fact, in the whole of this Exemplar wali book on chemical bonding is what I feel. Which of the following molecular orbitals has maximum number of nodal planes? Slightly tough question, guys. From atomic structure, you know that nodal plane matlab L. I hope you remember that. But the moment you go into molecular orbitals, anti-bonding molecular orbitals, you got to do L plus 1. This is the quick way of doing it. If you want details, you can also do that. So sigma would be 0, sigma star would be 1, pi would be 1 because L is equal to 1 over here, and pi star would be equal to 2. Which pi? Well, p, right? We are talking about p orbitals, which is why you've got L equal to, oops, I'm talking about sigma star p. That's interesting. Let's back up a little bit. Sigma star p, is that going to be 1 or is that going to be 2? Well, think about it, right? This is a slightly tough idea, Okay, I've told you confidently that sigma is 0 because it's S. But what about sigma star 2p? What about this? Is that 1 or is that something else? Well, the answer to this question, I feel that is going to be this. And you can check out the diagram on NCERT to make sure. And look at why there are 2 in pi and pi star. You can sort of figure it out. It's a little bit of a stretch. There you go. Right? There are 2 nodal planes over here. Okay? This and this. If you go to pi, if you go to sigma star 2p, this is the only nodal plane. These are nodes, sure, but those are nodal, that's a nodal plane. Okay. Tough question, not an easy one, not an easy one. So I feel the answer should be this. NCERT says, the exemplar book says something different. Yeah, that says that the answer to this is 66 should be 2, but I feel it's 4. You can check it out on your own and be sure about it. This is what I feel. Which of the following pairs is expected to have the same bond order? 16, 14. Count the number of electrons. If they are the same electrons, then sure. Here you got O2, 16 minus 1, right? O2 plus, and this is 14 plus 1. So 15 again. Yeah, I think this one works. You don't have to look at the rest. If you want to, we can. This is 13. This is 17. This is 15. Yeah, there you go. That looks like a B. Okay, 67.2 is the answer to this. Last question here. इसमें से the following molecules, sigma 2pz orbital is filled after किसमें? Okay. अच्छा. Well, I could brute force this, right? And say that if all I've got to do is see कितने is of these are less than equal to 14 or greater than 14. The odd thing here is this, so this must be the answer. You don't have to worry about actually thinking ये कैसे हो रहा है, right? क्योंकि सिर्फ एक है जो less than 14 है. That's why the thing changes. If you know the theory, you can also spend some effort on figuring that out. But just by elimination, you get that this answer should be 3. All right, that was chemical bonding. Do all the questions here, including the short and long answer ones. That will help you with your boards and other tougher exams. But I think for JEE Main, this should suffice.